Hi, today I want to talk to you about a paradox. And in doing so, we will explore the connection between financial markets, weather forecasts, messages in bottles, and even the shape of snowflakes. There is a common thread between all of these topics. I am speaking about chaos theory. So, if you want to know how investors are able to make money from chaos, get comfortable and keep watching. You have probably already heard that the evolution of market prices is a random process. Random means that it is literally impossible to make reliable predictions about the exact price of an asset. Of course, this cannot be completely true. Otherwise, there would not be so many investors that are able to consistently make profits. If the market was truly unpredictable, well, then investment funds and investment banks would not be among the richest companies on the planet. Unpredictable means that guessing tomorrow's prices is equivalent to guessing the outcome in a dice roll. When you roll a dice, the probability of guessing a certain number is 1 in 6. So, if we play a fair game, then when you bet, say, $1, you should win $6 whenever you guess right. So, on the long run, your expected win is actually 0. If you ever heard of asset pricing models or Black-Scholes equation, well, then you already know that most of the models used to price assets work fundamentally like a dice roll. And finding the price of a stock or any other financial asset is the same as finding the right price in a fair bet. But as I said, if active investing makes sense, then the market cannot be completely random. Or there must be at least one moment when making an investment is not like making a completely blind choice. And this is where chaos theory comes into play. You want to know how far ahead you can look into the future and hope to make reliable predictions? Well, chaos theory has the answer. But what exactly does chaos mean? First of all, chaos does not mean random. Let me explain you why with an example. Imagine you are in a desert island in the Atlantic Ocean, and you have two bottles with a message inside. If you release the two bottles at the same time and from the same point on the beach, you would probably expect that the waves transport the two bottles more or less in the same direction, right? Well, this is true, but only for a short period of time. If you could actually trace the bottle's trajectory, you would notice that at some point the two bottles start separating and would take completely different paths. So, after a few months, one bottle would end up in Europe and the other one in Australia. And this is true, no matter how close to each other you decide to release the two bottles. And this is an incredible phenomenon if you think about it. And it is also not that intuitive, because the movement of the two bottles in the sea is determined, after all, by the same laws of physics. When you play basketball, if you throw two balls from the same position and in similar directions, well, gravity guarantees that the two balls will fall not far from each other. But if you release two balloons at the same time and from the same standing point, well, the two balloons would fly in completely different directions. You can release 1 million balloons in the air or 1 million bottles into the ocean and you would observe 1 million different trajectories. And this happens just because all these bottles and all these balloons are released from slightly different positions. Only if the starting positions were exactly the same, with 100% accuracy, then the two balloons or the two bottles would follow the exact same path. And this is chaos. There is no randomness here, because everything is governed by very precise and deterministic laws. But the outcome is extremely sensitive to the starting conditions. So releasing one bottle even 1/1,000,000th of a millimeter away from the other would lead to a completely different outcome, making any predictions absolutely impossible. Now, we will see how to use chaos to our advantage. But let's first go back to finance for a moment. Financial markets are in fact very chaotic systems. Imagine you looked at Apple's performance over the last few years. And imagine that you could go back in time and change one small event in history. For example, that you decide to buy two iPhones instead of one. This small event would be enough, in theory, to completely rewrite Apple's history. For a while in this parallel timeline, the value of Apple's shares would follow a trend similar to the actual one. Then suddenly the stock would take a completely different course. Obviously, we have to assume here that everything else, every decision, every other action in this parallel universe remains exactly the same as in the actual one. Ever heard of the butterfly effect? Well, this is exactly what I'm talking about. There are, however, a couple of interesting properties in chaos. First of all, our bubbles in the ocean, at least at the very start, remain close to each other. This means that, at least for some time, making predictions is actually still possible. And chaos theory can help us determine how long it takes before chaos kicks in. So, in the case of our time travel experiment, there will be a short period of time where the two timelines of Apple's history have a similar behavior. This is the period where making predictions is possible. Chaos theory doesn't tell you how to make predictions, but it does tell you that it is possible. So, making predictions about the market is the same as making predictions about the weather. Also, the weather is chaotic, so we can still hope to make some good forecasts, but only for a few days in the future. If you wanted to guess what the weather will be in 1 year from now, well, then you would need to know the exact location of all the air molecules on the entire planet. A second property is that even if the two bubbles follow different trajectories, they will still follow very precise patterns. For example, if we release the million bubbles, we cannot know where they'll be in 1 month from now, but we know that overall the bubbles will tend to follow the ocean currents. These currents, or sea streams, are what mathematicians call attractors. And the same way bubbles are driven by sea currents, we expect that also stock prices are driven by some specific patterns. Finding these patterns is key to successful investment. And this is exactly what private investors or investment funds try to do all the time. There is one last very important feature about chaos. Perhaps the most important one, the so-called self-similarity. Now, imagine that you have observed the evolution of a stock over 1 day. Well, self-similarity means that if we extend our observation to 1 month, the trend over this month would still be the same as the one observed over 1 day, just rescaled. And the same holds true also if we look at an entire year. Self-similarity on multiple scales is a property typical of something that you have probably already heard about, that is fractals. For example, a snowflake is a fractal because the same geometry is repeated on several scales. Obviously, in the case of markets, it is not the same trajectory that repeats itself on multiple scales, but rather various properties, such as some statistical properties. Fractals are closely related to chaos theory and represent a fascinating world that we will explore in another video. But it already gives you an idea of why, to some extent, we can look to the past of financial markets to make predictions about the future. And it might also explain why extreme events like market crashes and financial crises occur more frequently than expected. These extreme events are called black swans. And this will be the topic of our next video. So, if you want to know more about black swans in financial markets, stay tuned and don't forget to like and subscribe. Thanks for watching.